Hey everyone and welcome. So over the next few minutes, we're going to totally break down the big ideas behind atmospheric changes. Have you ever wondered what actually makes the wind blow? Or why the sand at the beach gets scorching hot on a sunny day? Well, if you have, you are in exactly the right place. Let's get into it.
Okay, let's dive right in. But before we get into all the cool science stuff, let's do a super quick warm-up for our brains with a couple of English phrases that are actually pretty useful to know.
All right, first one up is off the top of my head. You use this when you're giving an answer really quickly, just from memory, without looking it up. Like, off the top of my head, I think the movie starts at 7. It just means you're not 100% sure, but it's your best guess right now.
And then we have never mind. This one's great. You can use it to tell someone, hey, don't worry about it, or it's not important anymore. So if you're looking for your phone and you ask a friend for help, but then you find it in your pocket, you can just say, oh, never mind, I found it.
Okay, warm-up's over. Now for the main event. You know, everything we're about to talk about, from the wind to the weather, it all starts with one single incredible power source. So let's talk about the sun's superpower. The sun is basically the engine for our entire planet. I mean, it's sending out this massive amount of energy that travels all the way through space to get to us. And you see, all that solar energy, it's what powers the whole water cycle, turning water into vapor, making clouds, and creating literally all the weather we see. Okay, so we've got the heat from the sun. That part makes sense, but how does that heat actually make the air move? Let's take a look at the invisible forces that create everything from a tiny little breeze to a huge, powerful wind. You know, to really get this, picture a simple experiment. If you take a little paper spiral and hang it over a lamp that's on, it'll actually start to spin all by itself. So what's going on here? Is it magic? No, it's just some really cool physics. Okay, here's the breakdown step by step. First, the lamp heats up the air right above it. Then, that warm air gets lighter. We say it becomes less dense, and it starts to rise up. And finally, as that air rises, it pushes against the paper spiral and makes it spin. Simple as that. So this whole cycle, warm air going up, cool air coming down to take its place, and then that air gets heated up too, it just keeps going. And this process has a really important scientific name, a convection current. This one is huge, so you're definitely going to want to remember it for your tests. And this right here, this is basically the #1 rule for how air moves. Warm air rises and cold air sinks. It's all because when air gets warm, its little particles spread out, which makes it less dense, kind of like a hot air balloon. The colder, denser air then rushes in underneath to fill the space. This one simple idea explains almost everything about wind. Right, so we know the sun heats things up. But here's a question for you. Does it heat everything up at the same speed? Absolutely not. Let's picture it like a race on a sunny day. A race between land and water to see which one gets hot the fastest. And in this race, let me tell you, land is the sprinter. It just soaks up that sun energy super fast, so its temperature rockets up. Water, on the other hand, is more of a marathon runner. It takes way more energy and a lot more time to get its temperature to go up. And you can see it right here on this chart. It's so clear. After just a few hours in the sun, look how much hotter the land gets compared to the water. And that temperature difference, that's the secret ingredient for things like sea breezes, and explains why it can feel so different at the beach compared to just a little ways inland. Phew, okay, we've covered a ton of ground. The sun's power, convection currents, and that big race between land and water. Now, you didn't think you were getting away without a little challenge, did you? Let's see what you remember. You ready? First one up. True or false? Land heats up slower than water. Think back to our race. Who was the sprinter? I'll give you a second. And the answer is false. Absolutely. If you got that, awesome job. Remember, land is the speedy one. It always, always heats up faster. Okay, let's keep it rolling. Next up, a fill in the blank. What's that one scientific word we use for all the water falling from clouds? You know, like rain, snow, hail, all of it? And the word you're looking for is precipitation. Yeah, that's the one word that covers everything. It's such a critical part of the water cycle. All right, get ready for the final round. It's time for the vocabulary speed run. I'm going to give you a definition, and you try to shout out the term before the countdown ends. You think you can do it? Ready, set, go. Okay, what's the name for the process that makes clouds, when water vapor cools down and turns back into liquid? It's condensation. Yes, you got it.
And what do we call that movement of heat where the warm air rises and the cool air sinks? What is that? It's convection currents. Fantastic.
Wow, you guys crushed it today. And hey, to make sure all these new words really stick in your brain, here are a few quick tips. Try connecting the English and Arabic words, or maybe draw a little picture for each word. You could even quiz a friend. Just find whatever works for you. So let's end with one last thought to chew on. We've seen how convection gets the air moving in our atmosphere, but where else do you see it? Think about a pot of boiling water on the stove, or even how a heater warms up your room. The point is, convection isn't just something in a textbook. It's happening all around you, all the time. Thanks so much for joining me.